Which of the following statements is correct about the periodic table? The question says, which of the following statement is correct about the periodic table? Option A is elements in the same period have the same number of valency electron. Option B said the valency electron of the element in the same period increase progressively across the period. C. Elements in the same group have the same number of electron share. D. The non-metallic properties of the element tend to decrease across each period. This is an option given to us. But remember, what we are doing is a what? JAMB CBT Chemistry Lesson Class 2. So if you are joining us, it's necessary you subscribe. So each class will post, you'll be able to receive prompt message about that. So the subscription is free. As long as you love the work we're doing here, subscribe, share it to your friends, comment. Now, let us look at the question. The question now said, which of the following statement is correct about the periodic table? We don't know. Now, let's go to answer. Period is the rows of the elements in the order of increasing atomic number or weight. Period is the rows of the elements in the order of increasing atomic number or weight. Then we now begin to talk about period. Periodic table. Periodic table is the table that shows the rows of the elements in the order of increasing atomic number. We are trying to get the words knowledge of what periodic table and period. We say periodic table is the table that shows the rows of the elements. Look at it, elements in the order. Come over here. Order of increasing atomic number. Then let us look at what we mean by periodic law. Periodic law states that the properties of the elements are a periodic function of their atomic number. The periodic law states that the properties of the element are the periodic function of the atomic number. Then let us look at the characteristics of what? Periodic table. Characteristics of periodic table. 1. The elements are arranged in rows in the order of increasing atomic number. The elements are arranged in rows in the order of increasing atomic number, called period. And there are 7 of such period. How? How do we know? We can say I use what? This, which we call 98. And the putting this configuration, electronic configuration, we say that 1x2. We now look at here is the first period. Now my first period take what? 2 electron. Second period take what? 8 electron. Third period take what? 8 electron. Check it. This is 2 electron for first period. 2 plus 6 give me 8 for second period. 2 plus 6 give me what? 8 for third period. Coming over here. 2 plus 10, 12 plus 6 give me what? 18. That's 2 plus 10, 12 plus 6 give me 18. Then my fifth period is what? 18. And the sixth period is what? 2 plus 10 plus what? 6 give me also 18. And my sixth period is 2 plus 14, which is what? 16 plus what? 10, 26 plus what? 6 give me 32. That my sixth period contains 32. And my seventh period is what? 2, 4, 2. Then what does it mean? I come over here to tell you that my first period will only be filled up with 2 electrons. My second period Second period will always be filled up with what? 8 electrons. And the third period will be filled up with what? Also 8 electrons. And the fourth period will be filled up with what? 18 electrons. And the fifth period will be filled up with also what? 18 electrons. And the sixth period is filled up with 32 electrons. And the seventh period is what will take us incomplete and take it as a long what? One, which waits for other discovering what element, other element that will be discovered are fixed in the what? 7 period. We now see the number of period we have and what filled each of that period. And what filled the first period is what? 2 electron. What filled my second period is what? 8 electron. Third period is 8 electron, and the fourth period is 18 electron. Fifth period is 18 electron, and the sixth period is what? 32, and the seventh period is what we call what? Incomplete. Number 2, the valency electrons of the element in the same period increases progressive across the period. The valency electron, are you seeing it? Of the element increases of the element in the same period increases progressively across the period. Let me repeat it again. The valency electron of the element in the same period increases progressively across the period. How? Somebody say how. Then now, look at sodium. Sodium have atomic number of what? 11. Then taking the electronic configuration of sodium, you see that first period, the second period, and third period. And look at the third period. Look at the electron that is the third period. 1. Magnesium. There is magnesium. 12. And look at the first period, second period, third period. See the electron that is the what? In third period. You see as they increasing progressively. Is increasing progressively across the period. Look at that. This one is period 1, period 2, and this is period 3. And this one is still period 1, period 2, and the same period 3. They are the same period 3, but the electron is increasing the what? Progressively across the period. It's just is increasing. This one is 1, this one now is 2. Coming to this, which we call aluminium 13. Electronic configuration, first period, second period, and third period. And you look at the electron in it, 1, 2. Look at the third period. How many electrons do you see there? 2, 1, making it 3. And you see as it's increasing. The same period. How many period this one have? 3 period, 3 period, 3 period. But the atmosphere electron continue what? Increase progressively across the period. Looking at silicon, we say 14, and we have this, and this, and this. And this is the first period, second period, and third period. And look at the electron in the last period. You said 2 plus 2 giving me what? 4. And this one is what? 3. This one is 2. This one is 1. And they're the same in the same what? Period, which is period 3. But electron in the atmosphere is what? Increasing as atomic number is what? Increasing. See that the electron is increasing across the period as the atomic number is what? Increasing. Look at the atomic number of this. It says from 11, 12, 13, and 14. As atomic number is increasing, the electron is what? Increasing across the what? Period. Across what? Period. You see it here. Then now, look at the word ribbons. We say 37, and you see the electron configuration is 6. And you look at this period 1, period 2, and period 3. And this is the period what? 4 and what? 5. You see how it's increasing progressively across the period. So when I say the characteristics, the second characteristics of what? Periodic table is the valency electron of the element in the same period increases what? Increase what? Progressively across the period. Yeah. Group is the vertical column containing elements with similar properties. Group is the vertical column containing elements with similar properties. We now look at characteristics of group. Since we have looked at the characteristics of periodic table, We are going to look at the what? Characteristics of group in that periodic table. Characteristics of group, we say number one, the elements fall into vertical columns called groups or family that have, come over here, that have similar property. That means element that's in the same group has similar what? Properties. They have the same properties. Then now, number two, elements in the same group have the same number of valency electron. Elements in the same group have the same number of what? Valency electron. Why did I say that? Reason, I said the outermost shell valency, electron tells us the group the element belong to. How? We said the outermost shell valency electron takes us the group which element belong to. And I said now, the first characteristic that say the group element that belong in the same group have the same what? Property, physical what? Properties. We said they have what? Similar what? Properties, both physical and what? Chemical. Then when I come to the other, let's say look at it. Sodium. Look at this first period, second period. Look at the last period, which is my outermost shell. My outermost shell is the last period here. And what elements do you contain? How many electrons does it contain? It contains one electron. You see that it contains one electron. And it means that it belongs to what? Group 1. This is my first period, second period. My last period, which is my outermost shell electron. And what contains one electron? It belongs to group 1. Then looking at magnesium, we say 12, which is the first period, second period, and the third period, and it has how many electrons? 2 electrons at my what? Outermost shell electron, and it belongs to group 2. This is what tells me the group it belongs to. The electron that is in the outermost shell electron tells me the group it belongs to. The electron that is what? Outermost shell electron tells me the group this man belongs to. So now we cannot answer our question. After we have gone through the characteristics of periodic table, study about periodic table, after we have gone through them, you see now you can be able to answer this question without wasting time. Then looking at the option given to us, we now find out that option B, the valency electron of the elements in the same period increase progressively across the period, just as what we have studied in the properties of what? Periodic table. As we have studied in the properties of periodic table, we find out now from that property that the valency electron of the element in the same period increase progressively across the period. So solution, my answer now, our answer become what? My answer become option what? B. Now, the question says the electron configuration of X losing 2 electrons, and look at the number of electrons, ion is, I'm coming again, the electron configuration of X ion is, they give me A, look at the option, B, look at the option, C, look at the option, D, look at the option. I don't know the rightful answer until I solve. Then let's go to the word solution. Remember to subscribe. Your subscription is necessary so that at any time we want to post the class 2, class 3, whatever we do, you'll be able to receive. Then subscribe, share, and comment. Solution. We'll go to solution. Look at this. This simply means that these elements or atom have loose electron, and it has a proton in excess. That means it has proton in excess, and this too is telling me that it has lose 2 electrons. What this man lose is 2 electrons, leaving excess 2 proton. Because proton and the number of proton and number of electron need to be equal in an atom, making an atom to be what? Neutral. A neutral atom need to be what? Equal proton and what? Electron. Make an atom what? A neutral. But immediately atom loses electron, the number of protons in that atom will be in excess. While the atom that received that electron will have an excess what? Electron. So this man loses electron, it implies that this man loses what? Electron. And what means minus? What does it mean? That he loses what? 2 electrons. Look at the electron. You understand? This is 0. The number, atomic number of electron is 0. While what? Atomic mass of electron is 0. While the atomic number is 1. So 2 times 1, this implies that this man become what? This man now become, this gives what? Means that he loses what? 2 electrons become what? This will not give us, this will give me what? As he loses 2 electrons, this will give me what? 20. And this will give me what? 20. And this will give me 2 plus. And that's what this man will. That this man loses 2 what? Electrons to be what? This. And the number of electrons here will be reduced, because for this man to be plus means that what? 2 electrons have what? Go out of this place. By removing the 2 electrons, I'll have what? 20. And that means the atomic number, remember that this, if I said Y like this is my atomic number, this is number of proton, which is the same thing as number of what? Electron. Then we can now write the electronic configuration of what? This man by saying, come over here, I have the what? The number of electrons there will be now what? 20. And I will say that is equals to 1. 1x what? 2. I will have what? 1x 2. And I will have what? 2x what? 2x2. I will have 2x what? 2. And I will have what? 2p6. And I will have again, what I'm going to have again, I will have 3x what? 2. And I will have what? 3p what? 6. I'm saying I have this is 20, I have this and this 4 plus this 10 plus this and this what? 18. And I will have what? 4x what? 2. And that's give me what? Look at it. 1, 4, 6, which give me 10. And this give me what? 12, 18, 20. That's I've exhausted the electron. That means I have exhausted the electron. 1x2, 2x2, 2p6, 3x2, 3p6, 4x2. Count it. 2 plus 2, 4, 6, 10, 12, 18, and what? 20. And when I look at it, I'll go to option they gave me here. I look at the option A, no. I look at option B, no. I have option C, no. And I look at option D. Look at this, and this, and this, and this, and that. That I want to say my answer is a what? Option what? D. My answer is option D. That is our correct. The question says, the knowledge of half-life can be used to what? A. Create an element. B. Detect an element. C. Split an element. D. Irradiate an element. Looking at this, we'll say solution. Solution. First of all, let us know what we mean by half-life. Half-life, which we represent with what? Half T. T subscript 1 over 2. That's what we call half-life. That's what we use to represent what? Half-life. So that anytime you see this, you know what we're talking about, what? Half-life. Is the time for half of a given sample of a radiative material to decay. Is the time for half of a given sample of a radiative what? Material or element to what? Decompose or decay. Then we'll say half-life is a formula. Look at the formula of half-life. Is equals to what? 0.693 over K. And what's decay? K is called what? Decay constant. K stands for decay constant. So where K is the rate constant, which we'll call again decay what? Constant. And I call it rate constant or decay constant. And this constant is constant for a particular what? Material. For a particular radiative element, this man is the what? Constant. Then now let us look at the uses. Let us look at the uses of what? Half-life. We say half-life is used to dictate radiative what? Elements and its age. we can use half-life to dictate what the age of a radiative element, and as well what dictate what radiative what element. So we see that we use half-life to dictate what radiative element. If I take a radiative element, I'll be able to, from its half-life, I'll be able to detect the radiative what element and its what age. Then let us go to option given to us. They said option A, create an element. We can use half-life to create an element. B, dictate an element. Yes, we can use half-life to dictate what? An element. Split an element. No. Then irradiate an element. My answer here is a what? Option. My answer is option what? B. That's option B is a an element X has electron configuration 1s2, 2x2, 3p6, 3x2, 3p5. Which, come over here, of the following statement is correct about the element? Which of the following statement is correct about the element? A, it is a halogen. B, it has a completely what? Filled p orbital. C, it has 5 electrons in its atmosphere. D, it belongs to group 2 on the periodic table. I don't know. Let's go to solution. Solution, you remember what they gave me there? What they gave me there is what? 1x2. They said what? 2x2. Again, 2p6. That's what they said the electron is. And 3x what? 2. And what? 3p5. That's what they gave me there. Then now for me to know, I have to start from my first period. My second period take 8 electrons. My third period take this. And this means the number of electrons at atmosphere tells me the group it belongs to. I look at this. 2 plus 5. That gives me 7. That means 2 plus what? 5. This 2 plus 5. Give me what? 7 what? Electron. An element that has a 7 electron is a what? Is a what? Halogen. So an element, it belongs to what? Group 7. Then we say what? It belong to group what? 7. And the group 7 is called what? And it is what? It is called what? Called halogen. Halogen, they are what? Group 7. Group 7 is what? Halogen. This is what told me the what? The group it belongs to. And the group 7 is a what? Halogen. And I go to option. They say option A, it is a halogen. Option B, it has a complete filled p orbital. Option C, it has 5 electrons in its atmosphere. D said it belongs to group 2 on a periodic table. No, the answer is what? It belongs to group 7, and the group 7 is a what? Halogen. My answer is option what? A. The question said the electronic configuration of an element is 1x2, 2x2, 2p6, 3x2, 3p3. They said to stop. How many unpaired electrons are there in the element? How many unpaired electrons are there in the element? They said the electronic configuration of an element is 1x2, 2x2, 2p6, 3x2, 3p3. How many unpaired electrons are there in the element? They say A5, B4, C3, D2. And I said to solution. Let us look at solution so that we know the one that option. And I said, how many orbitals do we have? We have what? X orbital. We have X orbital, and X orbital, and they're being paired up, which will have spin in and what? Spin out. That means X orbital is filled up. Then that imply, and what does it imply? Imply what? 1x what? 2. That's 2 filled what? X. 2 electron filled what? X. It means that it's paired. Then I have what? P orbital. That's the second orbital we have. P orbital, what fill it up? I have this. Watch, we have this, and this, and this. And this first filled and paired up. This paired. This filled and paired what? Up. This filled and paired what? Up. And this is called what? PX. PY. PY. And what? PZ. This. And this man are filled up. And that's implied that is what? P6. How many electrons? 6. Count it. 1, 2, 3, 4, 5, 6. Then I come to what? D orbital. We have D orbital. And that D orbital, I have this. That's 7. I have 1, 2, and what? 5. 1, 2, 3, 4, 5. That's for D orbital. I will have filling and pair. Filling and pair up. Filling and pair up. Filling and pair up. Filling and pair what? Up. And I will have this imply that what? My P, that's my D orbital taking what? 10 electrons. Check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's paired. Then I have my F orbital. F orbital. My F orbital has what? 7. That's 7. I have this 1, 2, 3, 4, 5, 6, 7. And I will have pin in, pin out. Pin in, pin out. Pin in, pin out. Fill in, fill out. Fill in, fill out. Fill in, fill out. Fill in, fill what? Out. Check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that means that 14 electron is what my P, my F take. That's F orbital. And that implies that my F orbital take what? 14 electron. Then now, coming to the one they gave me, come over here. Look at the one they gave me here. They gave me 1x2. They gave me 2x2. They gave me 2p6. They gave me 3x2. They gave me 3p6. But look at it. This man is filled up. Complete. X orbital 2 filled it up. Is paired. This one is filled up. Is paired. This man is filled up. Is paired. 6 filled what? The p orbital. This one is filled up. X orbital 2 filled x orbital. P 6 filled p orbital. Here 2 fill this x orbital. 2 fill it. Then the remaining one, the last orbital here is 3p6. 3p3. That's what they gave me there. 3p3. Look at it. Come over here. 3p3. Then looking at 3p3, you see that it's incomplete. It's supposed to be 6 versus 3. Then what does it mean? And I say look at p orbital here. And I have 1, 2. And I have what? In, and what? In. They are not what? Paired. And I have here to be what? X, Y, and what? Z. It means that how many is unpaired here? I'm supposed to have 1 coming out. 1 coming out here. 1 coming out here. And I said 1, 2, 3. That's 3. 3 orbital is unpaired. I can answer 3 what? R. 3 is what? Is what? Unpaired electron. 3 electron is what? Unpaired. That means 3 is unpaired. And I said, how many unpaired electrons are there in the elements? When I say that is what? 3 is unpaired. Look at it. Here is unpaired, unpaired, unpaired. And I mean 1, 2, 3. We said 3 electron is what? Unpaired. And my answer here in option C is my answer. I can answer my answer. My answer is option what? C. That means the question. The ions X and Y are isoelectronic, each containing a total of 10 electrons. That means these ions X and Y are isoelectronic, each containing what? Total of what? 10 what? Electron. How many protons are in the nuclei of the neutron? neutral what? Neutral what? Atoms. How many protons are in the nucleus of what? Neutral atom of X and Y respectively. They said what? A 10 and 10, B 9 and 9, C 11 and 9, D 9 and what? 11. How many protons are in the nuclei of what? Neutral atom of X and Y. Then we go to solution for us to be able to know what the answer is. You remember that this man have been accepted the electron and this man had what? Lose the electron after the reaction. And looking at it, before the reaction we have X plus what? Y. This is it before the reaction, which is the reactants. Then look at the product they form. They form a product which contains what? X giving me out what? Accepting electron, and the what? Y what? Losing what? Electron. That means this man loses the electron after the what? The reaction, and this man accepted the electron after the reaction. Then let us look at the what? Their electronic configuration before the reaction. That means this man before the reaction has, for them to have 10 electrons after the reaction. For them to have 10 electrons after the reaction means that this man which accepted, look at the minus, means he accepted the electron, having an electron in excess. Minus means electron in excess. That means for them to have 10 electrons after the reaction means that this man is a what? 9. The X is what? 9, which accepted the electron to be what? 10. Then, and the what? Before the reaction, that Y is a what? Y, which loses the electron, is a what? For him to be 10 after losing the electron, means that is what? For him to be 10 after losing the electron, means that is 11. After his 11, now he lose 1 electron, become what? 10. Why this man gain 1 electron, become what? 10. So now, this, they are electron before the reaction. Then now, why after the reaction? I want to look at it. The electronic configuration, coming over here, I want to say electronic configuration of X is equals to 9 before the reaction, and the electronic configuration imply 1x2 and what? 2x2 and what? 2p6, and that give me what? 2p5 will give me what? 9. This is the electronic configuration before the reaction. Then that my for Y, I have my Y to be what? 11 before the reaction, and that implies what? That 1x2 and what? 2x2 and what? 2p, then this 2p6 and what? 3x1. This is the state of Y before the reaction. If you check it, this 10, this is 11. Then now, after reaction, look at the after reaction. When this man have reacted, having an Sx is the minus, he accepted the electron, he become what? 10. Then, and this man loses the electron, which will become what? Positive, and this become what? 10. Have you seen the now have what? 10, 10. And these two become what we call isoelectronic. And that's what we call what? Isoelectronic. That means after their reaction, they have the same equal what? Electron, and we say isoelectronic. I cannot say the electronic configuration after reaction of this man, which implies what? 10, and they will have what? Which is 1x what? 2, 2x what? 2, and 2p what? 6, which is 10. And this man, Y, which is positive, which give me 10, imply what? 1x what? 2 as well. 2x what? 2, and what? 2p what? 6. And you check it now, 2 plus 2, 4, plus this give me 10. 2 plus 2, 4, plus this give me 10. And they have equal what? Electronic configuration. They have equal electronic configuration after their reaction. Why before the reaction? Look at the number of electrons. Then what they ask me now, how many protons are in the nuclei of the neutral atom? The atom is neutral before going into what? Reaction. When we say atom is neutral, is when it doesn't go to any what? Reaction. So atom that does not go to any reaction is neutral. So this is the neutral atom. look at neutral atom of X, look at neutral atom of what? Y. Then after reaction, they no more what? Neutral. They have their what? Exchange of electron. Why this X is neutral, and what's the value? We said is what? 9. Look at his value, 9. Then Y, what we said is what? 11. We say is 11 when it was neutral, because they said they asked us the proton when they are what? Nucleon of the what? Neutral what? Atom. So we now say that X is what? 9 and Y is 11. X is 9, look at it, X is 9 before the reaction, Y is 11. And I go to option they give me there. I will now see that what? X is what? 9. Look at X 9, what we said here, 9. X is what? 9. And Y is what? 11. Then I will say my answer is option what? D. That's my what? Correct. The question says, look at the question. The reaction between X and this X giving me oxygen and hydrogen. Then I said in the reaction above, X is A helium, lithium, B neutron, C helium atom, D deuterons atom. I don't know the answer. What they throw me is the reaction. I should find the value of X. I will not say solution. What we're going to do is to do what? Solution. And our solution, I know that what? This X 14 and what? 7. I can say plus. This man can be what? N. And this can be M for me. And that gives me O 17H plus H 1. And this implies that 14 plus N is equals to 17 plus 1 is equals to 17 plus 1. And this will give me that N is equals to 17 plus 1 will give me 18 minus this coming over here become 14 minus 14. And my N will give me what? 4. Then I can come over here to do the same thing again to say 7 plus M. That means 7 plus my M, this 7 plus M is equals to 8, which is this, plus 1, plus what? 1. And that gives me that M is equals to what? 8 plus 1 will give me 9, and 7 coming over here become minus 7, and I will say that M is equals to what? 2. Then coming here, I can now say that my what? N is equals to what? 4, and the M is equals to what? 2, and that's my X N M implies to be what? X, which is what? 4 and what? 2. And what does this imply? It implies what? Helium. That's what? Helium. That's what it means. It means what? Helium what? Atom. This is mass number of helium, and atomic number of helium is what? 2. And I will say that the element is what? Helium atom. And I go to my option, that's give me option C. The answer is what? My option what? C is my what? Answer.